Dear students, welcome to the video Statistics 1 Probability Distributions. Discrete random variable. A variable is said to be discrete and random if it can take only certain values that occur by chance. For example, you buy a carton of 6 eggs. There might be some broken eggs in the carton. So if x is to be the number of broken eggs, x can take values 0, 1, because I said there are 6 eggs in the carton. So it could be 0, 1, 2, 3, 4, 5 or 6. What does it mean? It means that the number of broken eggs in the carton could be 0 or 1 or 2 or 3, 4, 5, or all 6 eggs can be broken. Probability distributions. The probability distribution of a discrete random variable is a display of all its possible values and their corresponding probabilities. For example, in the previous case, I said there is a carton of 6 eggs, and x was to show the number of broken eggs. As you remember, as there are 6 eggs in the carton, so the number of broken eggs can take the value 0, 1, 2, 3, 4, 5, 6. So it will be the probability distribution table. Table is usually used in order to show probability distribution. So for example, the number of broken eggs here is 0, here in this column 1, 2, 3, 4, 5, 6. Then in the following examples, in the next part, you will see one by one you need to calculate the corresponding probabilities for each case. And remember that all these probabilities should add up to probability of x is equal to x in the sample space, always add up to 1. Now we will go further in the following parts and examples. Example number 1, a fair square spinner with size labeled 1, 2, 3, and 4 is spun twice. The two scores obtained are added together to give the total x. Draw up the probability distribution table for x. Now, each spinner is numbered 1, 2, 3, and 4. Now I construct a possibility diagram. Here spinner 1, here spinner 2, number 1, 2, 3, and 4. Spinner 2, 1, 2, 3, and 4. X is the sum of the numbers shown by spinner. So 1 and 1. 2, then here 2, 1, 3, 3, 1, 4, 4, 1, 5, then 2, 1, 3, 4, 5, 4, 5, 6, 3 and 2 will be 5, 3, 3, 6, 3, 4, 7, here will be 6, 7, and 8. This is possibility diagram. Now, these are actually your x, the numbers which will be possible as the sum of the numbers shown by the two spinners. So if I construct a probability distribution table, I need to have these numbers. First one is x, and here probability of capital X is equal to x. Now possibilities we have 2, 3, 4, 5, 6, 7, and 8, which will be 4 columns. So I need 4 columns, 7 columns, sorry. So here 1, 2, 3, and here overall will be 7. So I list all possibilities. We have 2, 3, 4, 5, 6, 7, and 8. Now probability that the sum is 2. As you see here, it is the only cell in which you see 2. So it will be 1 out of the total number is 16. So 1 out of 16. 3 appears twice. So it will be 2 out of 16. 4 appears 3 times. 3 over 16. 5 4 times. 4 out of 16, 6, 3 times again, 7, 2 out of 16, and 8 is 1 over 16. Now, to check whether or not these numbers are correct, just add these probabilities, which will be 1 over 16 plus 2 over 16 plus 3 over 16, 4 over 16, again 3, 2 over 16, and 1 over 16. Now 1 plus 2, 3, 3, 3, 6, till here 10, and it will be 16 over 16, which is 1. So these probabilities all together add up to 1. Example number 2. The following table shows the probability distribution for the random variable v. V takes values 2, 3, 4, 5, and 6, and you have corresponding probabilities. It says find the value of the constant c and probability of v greater than 4. Now, the first point that you need to consider always in probability distribution tables is that the sum of probabilities should add up to 1. So, plus c squared plus 0.01 plus 2c plus 0.05 and 0.16 should be 1. Now it will simplify to this quadratic equation. 3c minus 0.64 is equal to 0. You can factorize 0.2 and c plus 3.2 is equal to 0. Now c will be 0.2 here and negative 0.32. So it's negative 3.2. Now here, as you have negative 3.2 for this c, it will make this c plus 0.1 negative. We don't have negative value for probability, so it's not acceptable. So you should accept this one, 0.2. Now this 2c plus 0.05, it will be 0.45, and here will be 0.3, and here will be 0.04 if you replace c. Now next part wants you to find probability of v more than 4. As you see here, more than 4, there are two numbers more than 4 in the table. Once v is equal to 5 or v is equal to 6, which will be 0.45 plus 0.16, which is 0.61 as the final answer for probability of v greater than 4. Third example, there are spaces for 3 more passengers on a bus, but 8 youth, 1 man, and 1 woman wish to board. The bus driver decides to select 3 of these people at random and allow them to board. Draw up the probability distribution table for y, the number of youth selected. Now, here, as you have selection without replacement, you can use combination. Now let's see possible numbers for the value of y, which is the number of youth can be selected. As there are just 3 more spaces, so the driver should choose actually 3 passengers. But why can't take these values? As you have just one man and one woman, if you choose both man and woman, so you need to have to choose one more passenger from these youth, so y will be 1. Y cannot take the value of 0y, because if 0 youth is selected, you have just one man and one woman left, which is 2. So you need to have select at least one of these youth. Now, the second possibility will be 2. It means that 2 of these youth are selected plus one of these 2 man and woman. Or you can all passengers, all 3 passengers from these youth, and no man and no woman. So y will be 3. Now find probability for each of them. Probability of y is equal to 1, probability of y is equal to 2, and y is equal to 3. Now y is equal to 1. It means that one of these 8 youth are selected, so you need to select 2 more passengers from those man and woman, so 2 out of 2. The total possible selections is 3, because you are supposed to choose 3 out of, you have actually 8 youth, 1 woman and 1 man, so it will be 3 out of 10, so it will be 1 over 15. Now the second possibility will be to choose actually 2 youth, so 2 out of 8. You need to select 1 from this man and woman, so 2, 8, 1 out of those 2 over 3 out of 10, which is the total possible selections, will be 7 over 15. And the last one, you're selecting 3 out of these 8 youth, then 0 from those 2 man and woman over the combination of 10 and 3, which is 7 over 15. Now you can construct a probability distribution table here. Here 1, we have 3 values, so here y, probability of y is equal to y. Possibilities for y was 1, 2, 3. Probability of 1 was 1 over 15. Here 7 over 15. And again 7 over 15, which simply add up to 1. We already know that in order to find the mean when you have a frequency table, you need to use this formula. For example, x bar is equal to sigma fx over sigma f. Now if I split it, I will write f1x1 plus f2x2 plus fnxn. What does it mean? Each data times corresponding frequency, then add together over the total number of frequencies. So now I split into n fractions, f1 over f1 till fn x1 plus f2 over f1 then fn x2 plus fn over f1 fn xn. Now we already know that when you want to find probability for each data, you just need to have the ratio, the frequency of that item over the total frequency. It gives you the probability. So you can write it is probability of x1. It is probability of x2, which is relative frequency actually, and here Pn. So will be sigma P I x I changes from 1 to n. Now, in a probability distribution table for discrete random variable, actually the mean is referred as to its expectation. So from now on, if you want to find the mean or expectation for a discrete random variable, you can use this formula: sum of x times its corresponding probability on the sample space. Now, I write the formula for variance, then we go for examples. And we know that variance is a numerical value to measure the spread of data around the mean. Now, in order to variance for x in probability distribution table, we will use these formulas: sigma x squared p minus expectation to the power of 2. As you see, it is so similar to the formulas that you learn in chapters 2 and 3. Here P is actually relative frequency, and here is actually the mean for random variable, discrete random variable x. Now let's see some examples. Example number 4 concerning expectation and variance. The following table shows the probability distribution for x. Find its expectation, variance, and standard deviation. Now, formula for expectation is sigma x times the corresponding probability, which is equal to. Now, the first data is 0. Its probability is 1 over 12. Sigma means sum. Next data is 5 times 3 over 12. Next data is 15 times 5 over 12. And the last is 20 times 3 over 12, which will be giving you an answer of 12.5 as expectation. Now, formula of variance of x, if you remember, sigma x squared, s squared, probability of x minus expectation squared. So it will be, this notation means each, actually a square of each x is multiplied by probability. So it will be 0 squared times 1 over 12 plus 5 squared times 3 over 12 plus 15 squared times 5 over 12 plus 20 squared times 3 over 12 minus expectation to the power of 2. Expectation we found 12.5 squared, which will be equal to, at the end, 43.75. And we know that the standard deviation is root of variance, so it will be square root of 43.75, giving you an answer of 6.61. Thanks for watching this video.